For many in the world, the word nuclear waste brings up a lot of imagery. To start off, you start seeing reruns of your favorite TV shows like The Simpsons, like those large barrels of glowing goop. Also, maybe protesters around Yucca Mountain and environmentalists shouting out that there are no solutions. That's why in this video, I'm gonna share why deep geological repositories, or short for DGRs, are a safe and bulletproof solution to nuclear waste disposal. It's a permanent solution that works. Yes, and it's better than shooting nuclear waste into outer space, I promise you. For those that don't know, hey friends, my name is Osama. I have a background in nuclear engineering, and on this channel, I help demystify nuclear technologies by simplifying them. Let's jump into this video. All right, so the first myth is that nuclear waste can contaminate our drinking water. Before we jump into debunking this myth, I'm gonna share a little bit more about what DGRs are, or deep geological repositories. All right, so what is a DGR? A DGR, a deep geological repository, is exactly what it sounds like. It's a deep underground repository where spent nuclear fuel is permanently kept. The question is just how deep? Well, it's around 500 meters, so around half kilometer deep, depending on geology and the makeup of the land that you're gonna use. All right, so the question is, do you just dig a hole anywhere in the world and throw nuclear waste down there? Well, no, that's not true. The way it works is geologists, scientists, engineers, they site survey and select rocks which are known to contain groundwater for millions and millions of years. So there's several geological surveys and site analysis that takes place well in advance. These are uniform, stable rock bodies like crystalline or sedimentary rocks. And the secret behind this repository is that when you go that deep underground, water can only move through very microscopic spaces within the rock and the crystalline structures. And remember, the timelines here are in the millions of years. When you go that deep underground, water moves only 1 meter per million years approximately. Hence why these repositories disconnect the environment from water that we see and the water that we use for millions and billions of years. And within that time, highly radioactive nuclear fuel like this, it decays to that of regular uranium rocks. Remember, water in a deep geological repository will never interact with groundwater that humans will ever drink in their lifetime. Remember, the repository is strategically designed to protect the watershed. The watershed is where streams of water connect to that of groundwater. So remember, with this permanent disposal method, you're protecting animals, you're protecting our environment, and you're also protecting humans or potentially even alien life that might be here in millions and millions of years. Let's jump into the second myth, which is DGRs can destroy our environment. All right, so for those that don't know, you don't simply throw spent nuclear waste deep underground in a hole, right? There's a little bit more nuance and technology that's applied. All right, so you're using containers, you're using bentonite clay, and you're using a lot of engineering principles that were used by Mother Nature and really adapting those into technology that's used underground to contain this spent fuel safely. So to put it simply, you're taking spent nuclear fuel, which looks exactly like this. All right, don't be scared. This is not spent nuclear fuel. It's simply a prop fuel bundle, and you're putting it inside of copper-coated carbon steel containers. All right, so they're called UFCs for short, or used fuel containers. So you're putting them inside of these containers, which are then sealed. All right, and remember, these containers survive as long as the spent fuel is radioactive. So the question is, why is copper chosen? Why are these containers coated with copper? And the reason why is because it's corrosion resistant. Yes, when you place copper deep underground, it's not going to corrode and turn blue when it oxidizes like that of when it's in air, but rather it stays intact. It's very corrosion resistant, especially in a deep underground environment. Also, what's really cool about these copper coated containers or canisters is that they're made out of carbon steel, all right? And carbon steel is unique in such that it's super strong. It's strong enough to hold the weight of half a kilometer of rock, and on top of that, 3 kilometers of a potential iceberg. The reason why is because when you're engineering in the span of millions and millions of years, you gotta design for ice ages as well. And remember, ice is pretty heavy. So these containers have some incredible technology. The shape, the materials that are being used is specifically designed to withstand the pressure of that half a kilometer rock and then 3 kilometers of ice as well. Remember, spent nuclear fuel isn't like what you see in The Simpsons. It's not a big, large barrel of glowing goop. Rather, it's a solid. They're solid pellets that are ceramic, right? Ceramic pellets made out of uranium. And these pellets are more like your plates at home, okay? They're meant to survive lots of heat and pressure within a nuclear power plant. But at the same time, when you put them underground, they're just as durable. They can handle those extreme pressures. And also they're shatterproof as well. And yes, I promise you, they're even more durable than those Corel shatterproof plates that you've got at home. All right, so you take those pellets, which are ceramic and very, very strong and durable, and you place them within a metal. You wrap them in a metal called zirconium. So this is that bundle that you put these pellets inside. So cool fact is that the ring that I'm wearing right now, it's also made out of that exact same material, zirconium. And similarly, zirconium is a great material because it's also very corrosion resistant, and it's a very strong, durable material as well. And in turn, this is what's called a multi-layered approach. So you've got these pellets, which are made up of a very strong ceramic that are placed in a material, a metal, which is also very corrosion resistant, which is then placed in these copper-coated carbon steel containers, which are extremely strong and corrosion resistant as well. So this multi-layered approach, it's bulletproof, it's backed by science, and in order for spent nuclear waste to get out into the environment, those pellets, which are made out of ceramic, would need to dissolve. That's not very easy. It's not easy for your plates to suddenly dissolve. Then this zirconium would also need to corrode away, and then you would have the carbon steel containers, which would need to fail, and then you have the copper-coated canisters, which would also need to corrode over time. So this is what a multi-layered approach is made up of. And then you've got bentonite clay. Bentonite clay is really special because it locks in water and also prevents water flow. And on top of this, these canisters are placed in bedrock. So that's why deep geological repositories and the technology around this permanent disposal method works. It's a multi-layered approach that's backed by science. There's many tests that take place to make sure that this is gonna hold up for millions and millions of years, long enough so this highly radioactive spent fuel decays to that of regular uranium rock that's found in the environment. In short, if a deep geological repository was built, the environment would never see a radioactive hazard, right? Animals, the environment, humans will all be protected. Yes, deep underground is the perfect place to dispose of spent nuclear fuel. All right, so myth number 3 is that nuclear waste is not natural. So a lot of folks will be amazed to hear that these deep geological repositories have actually been inspired by Mother Nature. Yes, she is actually quite the engineer. All right, so an example that I can give is an area in Canada, Saskatchewan. It's where most of Canada's uranium is sourced from. And in Saskatchewan, there's a location which has 100,000 tons of uranium deposit. And these were found deep underground. And this 100,000 tons of uranium, which is radioactive, by the way, naturally, was found to be isolated from the environment for billions of years. No radioactivity was found on the surface. So there was no radioactive signatures. And what's interesting is that uranium is radioactive. And another interesting fact is that these uranium ore deposits were found in porous sandstone, which are known for water easily passing through them. So where it was placed, a location that it was placed underground in, was actually inferior to that of a deep geological repository. And still, no radioactivity was found on the surface or anywhere in the environment for billions of years. But what they did find was that this ore had a layer of clay that was protecting it from groundwater. And because of this, this prevented uranium from dissolving into groundwater and also provided a buffer to prevent water movement from those ore deposits into groundwater. So that's how incredible this clay is. And remember, bentonite clay is a special type of clay, which is even more superior at those properties for holding in that water and also preventing water flow. To add to this, humans in our deep geological repositories, we've added this copper-coated containers, these carbon steel containers, as an added mechanism, another layer within the multi-layered approach to prevent any radioactive hazards from seeping into the environment. So for those that say that there are no solutions, for those protesters that rant about nuclear waste and say that there are no solutions, they've got to know that solutions do exist. And the best solution is what Mother Nature had developed. We've learned from those concepts and we've taken them and optimized them. We've improved them and added even more defensive layers so that we have an even more robust and permanent solution for millions to potentially billions of years. All right, so the next myth is that nuclear waste is the longest lasting and most dangerous waste that's found on the planet. All right, so spent fuel is long lasting. It stays radioactive for a very long time. However, it's not the most extreme material that you can find on the planet. What's great about spent nuclear waste is that we know exactly how long is radioactive for, and also a radioactive hazard. Remember, we can do a lot of calculations with a great level of accuracy to find out exactly how this will decay in terms of radioactivity over time. Yes, I did a lot of these calculations in my undergrad as well when I was studying nuclear engineering. Also, another concern that people have is that radioactive waste is toxic. You may not know, but there are many other elements that are found across the world that are non-radioactive hazards, but extremely toxic. And their toxicity, unlike nuclear waste, does not decrease over time. So there's cadmium, there's mercury, there's arsenic, there's lead. So these are all naturally occurring elements that can be found in car exhaust. They're found in PVC solar cells. Remember, radioactive material starts to disappear the moment it's created. And another fun fact is that the most radioactive material found on the planet is plutonium. Gram per gram, plutonium versus caffeine is more toxic than plutonium. Yes, cool fact that I learned as well. All right, so remember, the amount of radioactive waste that's out there in the planet is negligible compared to the amount of toxic substances that can be found in everyday life. And what's different about nuclear waste and these toxic substances is that nuclear waste is safely contained, it's safely handled, and no human being on the planet has ever died from interacting with nuclear waste. However, on the other hand, when it comes to toxic substances, which are thrown into our environment through fossil fuel energy production, through our car exhaust, through manufacturing across the world, unsafe manufacturing practices, these elements are readily in our environments, right? They're readily going into our oceans and interacting with our environments. However, when it comes to radioactive waste, we have those solutions to dispose of it permanently, where the materials will never ever engage directly with the outside environment, with animal species, with humans, or anything else. So the risk of radioactive waste being produced from a zero carbon, zero emitting energy resource like nuclear energy, as compared to that of climate change using fossil fuels, there is no comparison. This is a very less risky option as compared to climate change, which is going to impact the lives of billions and billions of years. It's impacting our entire climate, our environment. So when you see things in that light, it gives you a better perspective as to nuclear waste and why it's not dangerous. It's actually an awesome resource. Humans know how to contain it. We know how to protect the environment from spent nuclear waste. And especially, we know how to do the math to see when it will go from its most radioactive to that of decayed to that of a natural surface level. All right, and the last very important point is that there isn't much nuclear waste in the world. And the reason why is because it produces a lot of electricity. It produces a lot of energy with a very small amount. For example, this one spent fuel bundle, it can provide 520 years worth of electricity for an average Canadian, which are the top 4 consumers of electricity per capita in the world. Yeah, so all the spent nuclear waste in my lifetime would fit into the size of a soda can, right? A standard soda can. So if you look at Canada, Canada has around all the nuclear waste stacked from the bottom of a hockey rink to the top of the boards. It would make up around 9 hockey rinks worth of nuclear waste, right? So that's not much for a country that has powered large parts of the country for over 50 years, over half a century on nuclear power. So not a lot of spent nuclear waste out there. So remember, spent nuclear fuel waste is neither the most dangerous or the most longest lasting in the world. Rather, it's the most dangerous waste form that we're actually doing something about. And we'll jump into the last myth, which is it's impossible to know what will happen in a million years. And this is the most fascinating part about designing a spent nuclear waste repository. Unlike manufactured goods like a car, which are gonna last you maybe a couple of decades, maybe if it's a Japanese car, it's gonna last you a little bit more. A deep geological repository is very different because it has to last for millions and millions of years. So you're no longer thinking in terms of years or decades, you're thinking in a timeline which is millions of years in the horizon. And this means starting from the very beginning, looking at rocks or location which are not prone to that of seismic activity. So there's no earthquakes going on in that location or have had earthquakes for billions of years. Next, you want a host rock which is not permeable to water. So you're placing this repository in an area which has low water movement. Also, the fact that the repository is located in an area which has a low mineral value. So aka you don't want it to be located right next to a gold mine where future civilizations might be digging. Also, any rock that usually has a high mineral value is typically not very good for a repository either way because it naturally has fractures within it. Also, the area must have low water resources, low exploitable gas resources, and also be designed for natural phenomena to take place, like that of climate change, so extreme warming of temperatures, or glaciation from that of another ice age, so kilometers worth of ice that would potentially be on top of this repository and act like another pressure on top of the rock that's already there. In a sense, you're decreasing uncertainty and also taking data which can be extrapolated across millions and millions of years. And remember, you're using real geological data, and also you're using engineering principles to make sure that spent nuclear fuel is being intact. You know, for example, the used fuel containers that are designed, the bentonite clay, how it's placed, how deep it goes underground, how the repository shafts are designed and maintained. There's a lot of engineering dimensions, but also that fundamental science work that takes place where geologists survey that area. It's an incredible feat, a deep geological repository, and an incredible solution for nuclear waste. So overall, there are the 5 myths about spent nuclear waste. If you're interested in checking out some of my other videos, I recommend checking out the video where I chat about how your lifetime spent fuel can fit into the size of a soda can. Well, hope you enjoyed this video. Till then, take care.